All right, so I'm pretty sure this is where we left off. So let's continue on. Yes. Okay, so use the given information to write a rule for the nth term of the arithmetic sequence. So we're writing the rule. The difference here is that, once again, or well, not the difference, the same thing for writing a rule for an arithmetic sequence is that we're going to need a sub 1 and d, but this time the difference is they didn't give us either one. So we're actually going to build two separate equations from what they did give us. One that has to do with the eighth term. Apparently, I'm just going wherever I want. Let's go back. Okay, so the eighth term, and one that has to do with the 27th term. Okay, so with that, I'm going to set up my two equations. So here goes. I'm going to say a sub 8 equals a sub 1 plus, for the n, since this is the eighth term, I would say 8 minus 1 and then times d. Then I'm going to do the same thing for the 27th term. So I'm going to say a sub 27 equals a sub 1 plus, this time 27 minus 1 times d. Then I'm going to simplify what I can. So I have, a sub, dear. Let's try this again. One of the things I can simplify is the fact that we know that a sub 8 is 21. So I would say 21 equals a sub 1 plus, here I will do that back distributing. No, I won't. Just kidding. I'm sorry. 8 minus 1. I'm trying to make it harder than it is. 8 minus 1 is 7, so 7d. Over on the second equation, same basic idea. I'm going to go through, and I don't know what I just did there. I made it really big. Okay. And I lost my tools. Okie dokie. Sorry about that. All right. So I know that a sub 27 is 97. So I'm going to replace. So I'm going to do 97 equals a sub 1 plus 26d. I'm sorry, I'm being a little distracted by my cat. It's trying to climb into a trash can. It's very amusing. Anyways, okay, so continuing on. Then I have two equations and two variables. So I'm actually going to use some skills way back from first semester where we did substitution and elimination to solve a system of equations. So on this, I think I'm going to stick with substitution because it's maybe a little bit easier. Sorry, just kicking my cat out. Okay, so substitution, I would start by solving for one of my variables. So I'm going to use this equation and I'm going to solve it for a sub 1. So I'm going to subtract 7d from both sides. So I have 21 minus 7d equals a sub 1. All right, so the idea here is that I don't know what a sub 1 is, but I can replace. So instead of a sub 1, I can replace it with 21 minus 7d. So I'm going to go over here to this equation, and instead of the a sub 1, I'm going to replace it with 21 minus 7d, like so. Then I'm going to simplify what I can. Try not to make it too hard on myself. Let's see. Since there's nothing in front of parentheses here, I don't really need those. I can just go through and combine like terms. So I have 7d and negative 7d and 26d. I get 19d and then plus 21. I think looks good. Okay, then I would need to solve for d. So I would do that by subtracting the 21. So I get, it looks like 76 equals 19d. And then I would just need to divide out the 19. And let's see what I get. So divide both sides by 19, and I get d equals 4. So now I have the common difference. That's one of the things I need. Yep, got it. So I'm going to take that then and go back over here and plug it in so I can find a sub 1. So I would say 21 minus 7 times 4, my common difference, equals a sub 1. So I have 21 minus 28 equals a sub 1. That gives me negative 7 is a sub 1. Now that I have my a sub 1, so check on the a sub 1, I can go back then and write my formula or my rule. So here goes. Writing the rule. So I'm going to say a sub n equals, and this is a place where I'm only plugging in the a sub 1 and the a sub d to actually write the rule. So negative 7 plus n minus 1 times 4. Then I would back distribute. A sub n equals negative 7 plus, got ahead of myself there, plus 4n minus 4. So a sub n equals 4n minus 11. And that comes from there. And there's your answer. Awesome. Let's go on. Then we have a series, arithmetic series. This formula is going to be S sub n equals n times a sub 1 plus a sub n all over 2. All right, so going on for the things that this means, sorry, got distracted there. S sub n, this is the sum to the nth term. Or we might say the sum to the last term, whatever it is. So the n is telling us what term we're adding up to. Then a sub 1 is still the first term. N is still the number. This one, it's going to be the number of terms. Or the number of the term. It's still the same concept there. And then a sub n, this is the nth term. And here's where we really think of this as the last term in our sequence, or series rather, since we're moving to series. All right, in words, S sub n is the sum of the first and nth terms multiplied by, this is not right at all. I'm sorry. Let me try this one more time. I just got ahead of myself. Okay, in words, let's try this in words one more time. Difficulty? No, come back. What are you doing? Okay, you're doing whatever you want. Let me go back. There's where we were with our crazy problem. Forward. It won't let me go forward. Why would it let me go forward? That's craziness. Okay, well, technical difficulties. Hold on. Let's see if it will let me now. Okie dokes. No. Okay. All right. So in words, the S sub n is the average of the first and nth terms. So you see a sub 1 plus a sub n divided by 2. So that's the average. And then that is multiplied by the number of terms. My deepest apologies for getting those words wrong. Okay, got it all right now. Moving forward. Okay, so we're going to use that formula to help us out. The formula says we're doing S sub n equals n times the average of the first and last terms. There we go. Like that. So in this one, we're trying to find the sum of the series, and we're given summation notation. So I need to figure out some information. I need to fill in everything, basically. I need to know the first term, I need the last term, I need the number of terms. So starting with the first term, how do I find the first term for anything? I plug in 1. So I can take this and plug it into my formula. So 3 plus 5 times 1. If I solve that, I get 8. That's my a sub 1. That's the first term because I plugged in 1. So that gives me a start on my formula here. I have 8. Okay, then to get the a sub n, the last term, in this case, the 20th term, I would plug in 20. 3 plus 5 times 20. That's going to give me 103. So 103. Awesome. And we're going to divide that by 2. Then I need the number of terms. That actually also comes from this top number. I'm starting at 1 and going to 20. I have 20 terms. So S sub 20. Counting up to or adding up my terms up to the 20th term, then I would simply figure that out. So let's do it. I have 20 times. Here's where a calculator would be definitely handy. That's going to be 111 divided by 2. So that's 55.5. And then we're going to multiply that by 20, which I didn't do in my calculator. 55.5 times 20. I should have been able to do that one in my head. Sorry about that. There you go. 1,110. All right. So on to the next one. Same basic idea. Find the sum. So we're going to use that formula. S sub n equals n times a sub 1 plus a sub n all over 2. Then I need all the information. So I'm going to start with the first term. I find the first term by plugging in 1. So I would do negative 2 plus 4 times 1. That's going to give me 2. So that's my a sub 1. And I'm going to go plug that in my formula. So S 2. There we go. And then I need the last term, which in this one is going to come in from plugging in 28. And so here goes. I would do negative 2 plus 4 times 28 equals, looks like 110. Let me try that one more time. 4 times 28. Yeah, 110. Okay, so that's my a sub n. In this case, my a sub 28. So I would do plus 110. Then the number of terms, again, also comes from that top number. It tells us we're counting up to the 28th term. So this is the sum up to the 28th term. Then I would grab a calculator and do some math here. So I have 28. When I add that and divide by 2, I get 56. And then multiply by 28. So I have 1,568. On to the last guy here, a house of cards. Write a rule for the number of cards in the nth row if the top row is 1. Row 1, sorry. And then what is the total number of cards in the house of cards if it has 14 rows? So we're trying to write a rule, first of all, part A, for the number of cards in the nth row, meaning if I say how many cards are in the 10th row, you could figure it out, or how many cards are in the 22nd row. So if I look at this, go back. Okay, I look at my picture in the first row. How many cards do we have? We have 3 based on that picture. Then in the second row, we would have 1, 2, 3, 4, 5, 6. Then in the third row, we would have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9. I hope that we can see that okay. So that means my sequence, if I'm building my sequence, I would be starting with 3, 6, 9, and continuing. So if I look at this, the pattern here, it looks like plus 3, and we would assume that continues. So this keeps wanting to jump to the end. Arithmetic, because that common difference is 3. We keep adding 3. So to continue this in terms of writing a rule, I would do my arithmetic formula for writing a rule. A sub n equals a sub 1 plus n minus 1 times d. If I'm writing the rule, I need a sub 1 and d. Well, I found d, and I have a sub 1, so I just start plugging them in. So a sub 1 is 3 plus n minus 1 times d. Then back distribute. A sub n equals 3 plus 3n minus 3. I get a sub n equals 3n. These combine to make 0. So you can put in a 0 if you want, or just leave it at that. So there's part A. Then for part B, it says what is the total number of cards. So this is where we would jump to a series where we add the terms together. So we would do 3 plus 6 plus 9 plus whatever. We want to know what the total is if we have 14 rows, or if n equals 14. That would be 14 rows. Okay, so our formula for that is S sub n equals, sorry, I fell out of my head for a second there, n times a sub 1 plus a sub n all over 2. Okay, and then, whoa, come back. Awesome. Okay, and then we would need to plug in. So we need to know the first term, we need the last term, or the nth term, and the number of terms. So we know the number of terms is 14. That's what they're telling us. 14 terms. And then we know a sub 1 is 3. We already have that. The thing that we don't know is what is the last term, or the 14th row, how many cards are in that. We got to know that. So we can go back to our formula from the first one and figure it out. So go back to this guy right here, that formula, and we can plug in 14 and figure out what is the 14th term. So a sub 14 would equal 42. So in the 14th row, there should be 42 cards. Plug that back in over here, and we get that. Then if I, whoa, come back, there we go. Okay, so then I get S sub 14 equals, let's see, 14. I'm going to need to erase that arrow. Just took up all my space there. There we go. Okay. Then 14 times, let's see, we have 17 divided by 2. So 8.5 times 14. I get 119. All right. And so that answers question B. There would be 119 cards in the stack if we add them all up. Okay, that's it. Have a great day. Make sure you guys write down your homework. It is on the next slide that I keep flashing to. There it is. And we will see you on Monday.